We have a theorem here that if two isosceles triangle have common base, the line joining their vertices bisects them at right angle. This question is varying uh, from the congruent triangle. We are here proving that the triangles, that is, isosceles triangle having two sides are equal. As we know that the isosceles triangle have two sides which is equal. But here is a catch, that is a common base with the another triangle, which is also isosceles triangle, and the line between the starting point to the next to the another triangle is bisects the both triangle at right angle. So first of all, we have to consider the diagram first. So we have a diagram here. First, we have to mention that this is a isosceles triangle. First one is this, okay, and then second one is also a sorry. Second one is also okay. Second one is also a isosceles triangle, but the base is common. This is the base, which is common base. Okay, so uh, we are mentioning it as A. This is B, and this is C. So it will be D. Okay. Now we have a joining from here to here. That is A to D. A to D, when we are connecting them, this will bisect the both the triangles at 90 degree. That is the right angle. Okay. So we have to prove that this is the right angle when it will bisects from A to D. The both the triangles are bisecting. This will be at 90 degree. We have to prove that. But also there is a probably another aspect, that is a triangle which is also isosceles triangle, which is also a isosceles triangle. Both have common base. Okay, then this is also a triangle which is having common base, and this will bisect at 90 degree. This will bisect at 90 degree. So we are mentioning it as A, B, C, and this is D. And we are mentioning it as E. Okay. So we are mentioning it as E. Clear? This is clear. We have two aspects. That is first, and that is second aspect. Both have common base. Both are at right bisects at right angle. So starting with the concept we have. So given, what is given to us? It is given that two isosceles, two I, so sorry, we have to extend it. Isosceles triangle, triangles ABC and DBC having the common base, common base BC, that is we have discussed earlier. on base BC such that AB equals to AC, that is the formation of isosceles triangle, and DB equals to DC. Is, is it clear there? Okay. Then we have to prove what we have to prove. What we have to exactly prove that AD bisects bisects DC at right 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 angle. Prove in in triangles ABB and triangle ACD. That is discussed earlier that E A B D, and if you are talking about this one, A B D is a triangle, and A C D is also a triangle we are discussing here. So we have to extend it so that we can clearly see the image also. This is the image. This is the figure where we have to discuss. Now we are taking both the triangles in triangles ABD and ACD. We have what we have AB equals to AC, that is AB equals to AC. We are taking the triangle, this one. First of all, this triangle we are taking here. I'm mentioning this. And second one is this triangle we are taking. Okay. So I have mentioned that both the triangles so that we can clearly see it. And AB equals to AC is given. It is given. And BD equals to CD, that is also given it is a it is a isosceles triangle, and AD equals to AD as it is the common side. Sorry, common. So by SSS triple S criterion of congruence triangle triangle ABD congruent to triangle ACD. Now congruency is clear that with the help of triple S criterion of congruence, both the triangles, which one? This triangle with the common base of AD and this triangle with common base of AD are congruent now. If we are talking about this ABD and ACD, okay, both the triangles are congruent now. So we have to prove that angle. So now we are mentioning some angles here. Angle 1, we are talking that this is angle 1, this is the angle 2, and This one is angle 3. Okay. This one is angle 4. Okay. So it is clear that we have a angle, angle 1 equals to angle 2. Sorry, we have to increase it. Okay. Angle 1 equals to angle 2. That is due to the CPCT. That is because of CPCT. CPCT is congruent triangle of congruent part of corresponding part of congruent triangle, and angle 1 equals to angle 2. Now, now in triangle ABE and triangle ACE, we have what we have, that AB equals to AC, that is given because of the isosceles triangle, that is given here, and angle 1 equals to angle 2 because of CPCT, as we have proved for in earlier case, that is CPCT congruent triangle, corresponding part of congruent triangle. Sorry, and AE equals to AE, that is common between both of the triangles, common between the both of the triangles. Okay then. So by SAS congruency, congruency, the triangle ABE congruent to triangle ACE. Okay, triangle ABE is congruent to triangle ACE. Now, this is congruent so that BE equals to CE. What is B and C here? Here we have BE and CE. These are the points. These are the lines which are now equal because of the CPCT. Because of the CPCT, corresponding part of congruent triangle. Now, angle 3 will be equals to the angle 4, but there's a catch. If we are talking about that this is a straight line, that BC is a straight line, now there is a catch that that BC is a straight line, then then we have linear pair. Linear pair makes 180 degree. So angle 4 equals to angle 3 because of the linear pair. By linear pair. Okay, then now, so, so sorry, plus equals to 180 degree, 180 degree bilinear. Okay, angle 4 and angle 5 will make 180 degree. So we have angle 3 equals to angle 4 because of the CPCT. So that 2 of angle 3 equals to 180 degree. Now angle 3, angle 3 equals to 180 divided by 2, that is 90 degrees. So angle 4 will be also 90 degree because angle 2 and angle 3 and angle 4 are both are equal. Okay, so angle 3 equals to angle 4 equals to 90 degree. That is clear here. So hence AD bisects BC at a right angle. Hence it is clear that okay, now the question is solved.